All right, so the last unit is a unit on differential equations. And in the past, they always put differential equations on there with a slope field that's drawn, or when you have to draw. This year, they have to test everything using free response. I don't really know, but I do expect you all to see a differential equations to solve, because it does test your ability to do integrals, and sometimes they'll throw in a tangent line question in there, and then maybe a concavity question. So there's a lot they can test using a differential equation. So anyway, our differential equation is dy over dx equals the quantity y plus 5 times sine of x. And we're going to let y equals f of x be a particular solution to the differential equations with initial condition f of 0 equals -4. And the function is defined for all real numbers. So the A part, we have a slope field, and we're going to sketch the curve through the point 0, -1. All right, 0, -4, sorry. So we go to 0, -4, and we have a point. Sometimes that point is given to you. Sometimes you have to do it yourself. In this case, we need to make our point, and then we're going to follow the slopes going to the left and to the right of that point. So this is not easy to do on that iPad, but I'm going to try. So as I go through each little section, I'm trying to just mimic the slope. And sometimes you can go like right through a slope. That's helpful. All right, when I get up here, you can tell we're going to just change direction. And I'm still just trying to be the same slope as the ones above and below. I think I got off just a tad right there. Okay, not too bad. I already tried this once on this iPad, and going to the left for me is so much harder. Don't know why. Yeah. Sorry, you guys have to watch me do this. I'll try to see it. I'm just not getting it quite right at the beginning. It's messing me up through the rest of the problem. I really wish I knew how they graded these. Okay, so now for B, we're going to write an equation for the tangent line of the solution curve in part A at the point 0, -4, and then we're going to determine if this tangent line is an overestimate of f of 0.1, and then we're going to justify our answer. So to get a tangent line, we've reviewed this so much, so I think you guys got it. We need to find the slope, and the slope is found by using the derivative, and the derivative is what is given to us. So this one's a little different because x and y, we have to plug in an x and a y, but it's no big deal. So we're going to put -4 in for y, and we're going to put 0 in for x. And then looking at our graph, I think you guys can tell that the slope at the point 0, -4 is 0, but we can still go through the whole process where that's going to be 1 times the sine of 0. The sine of 0 is 0, so our slope is 0. Alright, and then a line with a slope of 0 is a vertical. a line with a slope of 0 is a horizontal line, and the horizontal line through the point -0, -4 is y equals -4. Okay, and I kind of already knew that was going to happen, that this tangent line is just this vertical line right here. All right, and then what point are we doing? We're doing point 1. So if we wanted to use that to estimate point 1, it'd be about right there. I can tell by looking at the graph that it's an underestimate because that point is below the actual curve, but that's not going to be enough to justify. So to determine if a tangent line is an over or under approximation, we need to know the concavity. And to find concavity, we need the second derivative. So I'm going to take dy over dx, and I'm going to find the second derivative. Now to do that, I am going to have to do the product rule. Okay, so I will leave the first one alone, y plus 5. And multiply by the derivative of sine of x, which is cosine of x. All right, plus, and then I will leave the second one alone and multiply by the derivative of the first one. And the derivative of y plus 5 is going to be dy dx. We're having to do implicit differentiation here. Okay, so then at some point when you're finding the second derivative, you have to plug in the first derivative. So in the place of dy over dx, I'm going to fill in what dy over dx equals. Okay, so this is going to give you y plus 5 times sine squared of x as your second derivative. All right, and what we want to know is at the point 0, -4, if this is positive or negative, and that will tell us our concavity. Now I can tell by looking at what I drew that it's concave up there, but it's possible that my drawing was wrong. I did struggle quite a bit. So I'm just going to take that negative or 0, -4 and plug it in. This is going to give us 1 times the cosine of 0, which is 1, and then 1 times the sine of 0, which is 0. So it's going to give you 1. And so because the second derivative is less than 0 at 0, -4, f of x is concave up there. And f of 1 would be an underestimate. Sorry, I've been doing this too long today. There. Okay, so now the big problem. These problems in the past have been like 5 or 6 point questions. So we are going to find the particular solution with the initial condition f of 0 is -4. So we're not going to use the initial condition quite yet. So I'm just going to go ahead and rewrite the problem. And the first thing we want to do when we're solving these differential equations is separate the variables. So y is on one side, x is on the other side. The only thing you can use to separate the variables is multiplication and division. So I'm going to multiply by the dx to move it over with the sign of x. I'm going to divide by y plus 5 to move the y's on one side. Okay. Then, and you always get a point for that. So that is a fairly easy step. You can definitely get a point. Then I need to integrate both sides. Okay. So if you have something in the denominator, like I have here, and it doesn't have a power other than 1, then whenever we find this, integral, we are going to use the natural log. Now, if there is a power, like a 2 or 3, we need to bump it up to the top and make it negative power. But in this case, we are going to have to do the natural log. Now, double check what's inside the absolute value. If the derivative of that isn't 1, then you are going to need to multiply by the reciprocal of the derivative. But in this case, we're good because y doesn't have a power and y doesn't have a coefficient, so we're fine. All right, and then don't forget the antiderivative of sine is negative cosine of x, and then plus c. Now we did a lot of these that we ended up with a natural log, and most of the time we would wait to use the initial condition. And I started this problem that way, and it was a pain, and it just didn't work out right. And so in this case, it's easier if we go ahead and use the initial condition here. Now, on all the others that don't have natural log, this is where we do the initial condition to find what c is. So I am going to plug in -4 for y. I am going to plug in 0 for x. Now the reason why this one worked out easier is because we get the natural log of 1, and the natural log of 1 is 0, because you're trying to figure out e to what power gets you 1, and that power is 0. And if you guys are using a graphing calculator, hopefully you've downloaded one on your phone or on your computer or something, then you can type that in if you forget. And then the cosine of 0 is 1, so the negative cosine of 0 is -1. So we're going to get that c is 1. So I would go right back to where I was when I drew this arrow to use the initial condition and put 1 in for that c. Alright, and then I'm going to solve this for y. And to solve for y, I am going to have to exponentiate. Alright, and then the reason we do that is to get rid of the natural log. Alright, and then for now, I'm going to put a plus or minus here. It is going to only be one of those. Okay, so this is where you're checking that initial condition. So I need to be able to plug in 0 and get -4. So you'll have a calculator and you can just try it different ways. But the way to get -4 is if this thing right here gives you 1. positive 1, because 1 minus 5 gives you negative 4. So the final answer is the positive. All right. And you are probably going to be a little forced for time, but take the time to type this in your graphing calculator and then see if your graph looks anything like what you